So we are simply going to, all you're doing is verifying today. Actually, I should say this. Several of you just asked me this question. Let me say it again. When you're verifying and proving the two sides equal, you cannot move anything across the equal sign. You can't add something over to the other side. You can't multiply both sides by something. What's on the left stays on the left. What's on the right stays on the right. You just have to change them using the identities and algebra. You can work both sides and get them to come out equal. You don't have to just change one side. You can be changing both sides to get it to come out equal. But in this case, couple tips you already know. Yes, if you don't see any other way to go, you can always change everything to sines and cosines because there's an identity over there that changes every single one of them to a sine or a cosine. Cody, I am not going to listen to you talk through this. You just talk through everything else. One more time, you're going to be up here on this corner. If you're adding or subtracting, yes, you need to make common denominators. You're doing fractions. Common denominators are going to be your friends. Okay. I want to get some more tips out of this, though, and this one tends to bug people. What bugs you about that problem?
Fourth.
The fact it's fourth power. That's big. We don't really want fourth powers. You start seeing big powers like that, you should start thinking, I'm going to factor.
What about B?
What
about I'm going to die?
B is just the letter we're using for the variable, for the angle.
Or is that the X? I don't like it.
That's actually, it's actually supposed to be B with a tail, so it's actually beta.
Yeah, so change that over.
You'll live with it. You can change it on your paper.
I like omega.
Okay, so.
But that's beta.
You a frat? Is that what you said? Beta?
If you have powers that are larger than 2, look to factor. It's probably going to happen. Can I go back?
Yeah.
Okay. So, how do you factor something to the fourth minus something to the fourth? If I'm telling you you need to factor it, what can you do to factor it?
Well, it's just the same thing as squares, but
Yes, it's the same thing as perfect squares. So you're going to unfoil it, so it's going to have to be cotangent to the what? Yeah, so cotangent squared and a cotangent squared in the front of both parentheses. And then in the back, it's going to have to be what? Cosecant squared. And then what do you know about the signs anytime you're doing?
it'd be plus or minus
Yeah.
the conjugate.
They've got to be the conjugate.
Always plus minus.
If it's, perfect squared is always,
If it's 2 factors or whatever.
yes, it's going to be a plus and a minus. Okay, that still looks awfully messy, but you're seeing cosecant squareds and cotangent squareds. You start seeing squareds that are added and subtracted, which identities should you be looking at? You should be looking at the Pythagorean identities, 6, 7, and 8. So, could I...
Equal 1.
One of them is going to equal 1. Which one? If I took and I rearranged number 8 to say cotangent squared, I'd have to subtract cosecant squared. Which then, what would I have to do with the 1?
Yeah, so it's a negative 1?
Yes, it would have to go to the other side, so it would equal negative 1.
So just change
But wait a minute, we could do it and make it easier, it's like positive, right?
Well, but you're changing this. So we can say up here that cotangent squared minus cosecant squared.
You just change it over to negative 1?
Yeah, you can wipe that whole thing out and it's negative 1.
Okay, then just change, then you can change that one.
Now, just because I'm a little crammed for space here, I'm rewriting. So I would now have a negative times cotangent squared plus cosecant squared. Okay, now, you might need to work on both sides, but definitely you need to keep an eye on the other side. The other side has only cosecant squareds in it. So is there a way I could get this side to be all cosecant squares? Where'd you get 2 cotangent squared? Where are you seeing that? Okay. It's kind of like what I just did, but not the exact same as what I just did with number 8. There's no way I can get number 8 to say cotangent squared plus cosecant squared. There's no way I can get exactly this. So what I want to do is I want to leave this cosecant here, because it's cosecant squared, that's what's up there, I want that. But I want to change this cotangent squared into something that's got cosecant squared. So yeah, if I take number 8 here, what does cotangent squared equal? If I get cotangent squared by itself. Yes, it would be cosecant squared minus 1. So I'm going to take that and I'm going to replace this cotangent squared with cosecant squared minus 1. Which now, I just replaced the cotangent squared with this whole thing. Because cotangent squared equals this. I took number 8 and I just subtracted the 1 over, is all I did, yeah. Yeah, well actually, I would like to add my like terms first. Cosecant, yeah. Because I don't want to lose anybody. Cosecant squared plus cosecant squared would be 2 cosecant squared. And then since I have the negative on the outside,
Plus 1.
if I distributed it, wouldn't it be what I have over there on the right-hand side then? Yeah. So I'd have negative 2 cosecant squared plus 1. And they would be equal. So you'll notice we did actually that entire problem with identity number 8, but we had to use it in more than one way to get to the answer, to get to come out equal.
So are you suggesting do one side first? Where did you get the one side? Where did you get
I'm telling you, I tend to start, what I do is I start with the side that looks messier. It's easier to get messy and make it simple. So I usually start with the side that looks messier, work it to a point, start looking at the other side going, okay, now what do I maybe need to do to get them equal?
So when we have
There's not
like,
going to be very many of these on the test because it takes long.
Yeah, there's...
And it's going to be a lot of brain work. It's going to be a lot of smelly air.
Smelly air? Brain work causes smelly air?
You have to clean out the factory first. Your brain doesn't run on full.
Okay, if you say so. Okay, so this kind of leads to a tip. With this time we tried to get, since the other side had cosecant, we tried to get this side all in cosecant. So that's another tip to the list.
so I got
You want to try to change both sides to the same trig functions. It can be any of these, yes. So you want to get your two sides alike, then you can start trying to get them to actually be equal. Okay. Can I go back again? All right. For my time-wise, we're good. All right. So let us try another one. I want to get that one.
I have.
All right. So you look at this baby and you go, whoa. The left-hand side is sines and cosines, and the right-hand side is a cosecant.
Let's say left hand.
So, which side do you think you want to work on?
Right. Because when in doubt, change it to sine and cosine.
Okay, when in doubt, change sine and cosine. If the left side's all in sine and cosines, wouldn't it kind of make sense we might as well get the right side in sine and cosine? So yeah, that's probably not a bad idea. What can I do to a cosecant? Number 1, yes, so I can change it to 1 over sine. Oh goody, now I have a fraction in the denominator of a fraction. Yeah. So I have to make before I can get it out of there, I've got to get the bottom added together into one fraction.
It's just gonna be a sign on the top. And
Yeah, because isn't one the same thing as sine over sine if I make a common denominator?
It's gonna end up being just one.
However, you convert this all to one fraction. That's sine x plus 1 all over sine. Get that in one fraction. Now, I have 1 divided by a fraction. What do?
Flip it over.
You flip it over, yeah. You're going to flip the bottom one over. So if I take this bottom one and I flip it over, I'm going to multiply by sine over sine plus 1. And since I'm multiplying it times 1, I have sine over sine plus 1. So I'm just flipping it. Okay. And at this point, I would say that side looks pretty simplified. I'm not seeing a lot I could do with it. It's not sine squared. I'm, at the moment, at least stuck that I might go try to do the left side and see if I can get it close to that.
Well, on the left side bottom, can't you like FOIL or back that?
You can factor the bottom left. What's the one thing that bugs you about the whole left side? It's backwards, you're right, but it's got one cosine squared, and the entire rest of the problem is a sine. And we see we've got all signs over here.
Here's cosine to sine minus 1.
So I want to get cosine squared, rid of cosine squared, I want to get it in sine, so I got this whole problem in sine. You are close, but you're not quite saying it right. You are. We need to rearrange number 6 to say, what would cosine squared equal? There you go. If you left cosine squared alone, you'd have to subtract sine squared. So cosine squared is 1 minus sine squared. We're replacing it with that. And then I got this ugly thing on the bottom. I can cross the ones off, yes. The ones are gone. I guess I want my notes to make sense.
I know you're right.
That's what he's looking at. Okay, so
Do it. Right now. Oh, wow.
what's bugging you here now?
Negative sign.
It's backwards, but you know what, guys? You can factor if it's backwards. Your brains can do it. Yes. You could. Baloney. Dude, factor it. What are factors of 3? 3 and 1, okay. What are factors of sine? You're just putting them in the opposite side of the parenthesis. Really? Is that hard?
It affects our brain, our visualizing.
Then it's time for your brains to have a new challenge. Okay? Now, do your outsides and your insides. I'm going to get a 3 sign and a 1 side, and I need to come out with a positive 2. Negative, positive, thank you. That's going to give me a positive 3 and negative 1, which will make positive 2 in the middle. Okay, if the top one is bugging you, because since it's a negative sine squared, let me point out that that means it's just the same thing. I'm going to rewrite it so I don't lose anybody here. I'm going to write it in reverse order so that you see it. What can you factor there? Bingo. Thank you, Colin. You can take out a sign. And then, oh golly gee, if I take out a sign, what's going to happen? I'm going to cross some stuff off. I'm going to be done. Because I'm going to cross off the 3 minus signs and I'm equal.
Genius.
Yeah. So, pretty sweet actually. It just takes practice, takes a lot of algebra. Don't be messy and sloppy and lose yourself in your work. There's nothing worse. Okay. Can we do 45? No. We can't do 45. Because I'm going to let you all work on it in class and then I'll come help you with 45. But I'm not doing it today. I'm torturing you. Oh, thank you.